Okay, I'm just checking this is recording because I've messed this up a couple of times and just got the audio. Okay. Seems to be okay. So the first thing to check is that after motion correction is after smoothing, you should see there should be an SWA task file. Okay, so this is smoothed, W for warp for normalized, and A for slice time corrected. Motion correction co-registration was written to the header, but not resliced, so there was no new image created at that time. So the first thing we need to do is to do quality control. It's really important to do quality control because basically, a lot of time data is rubbish or things go wrong, and if you don't know, it'll become much more of a hassle later on. So quality control basically takes two primary steps. One is to check the motion parameters, and here's a piece of code that can search for the motion parameters in a folder, and then, well, just for one anyway, and loads it up and reproduces these plots. So you basically searches dir, just searches in a directory for something, starts with RP and ends in .txt, and then uses text read to load it up, and then we plot it. And that gives us basically translations in the X, Y, and Z axis, and rotations around the X, Y, and Z axis here. Okay. So once you've done that, you can identify any spikes or anything like that. The general view is drift of more than one voxel, so 3.3 millimeters roughly is a problem, or spikes of more than half a millimeter. So that's kind of movement between one volume and the next of more than half a millimeter can cause real problems, and need to do something to try and deal with it. The advice usually would be to just junk the data, but I know with supervisors and stuff it's very hard to convince them because the data can be hard to get. But certainly if you've got patience, they will move more than controls, and it's an important thing to try and control for. Okay. So apart from checking for motion parameters, the next thing is just to check the images look like they're filling the M&I space pretty clearly. So we do that using this tool, oh sorry, not that one. This tool here called check register. So if you click that, click check register, it'll ask you to select some images. So if you remember before, I said that in this option here previous, you can move between different folders, but SPM is always listed at the top. So if you click on there and go into the folder called canonical, that's just got a number of images which are normalized into M&I space. So we'll just grab one of those. Don't press done because we need to go back and get the files we want to look at. So click here, back in your original folder, in your SPM course folder, and you can see the files. So let's filter here for the SWA task file. 1:300. Now we don't want to select all, we just want to select one or two images, or a few images. So I always take the first two images, one from kind of halfway through, so something like that, and one from towards the end. And they'll all be displayed on the same graphics window now in a second. So this is the target, this is M&I space, and this is our data that's been normalized. And you have to remember there will be some susceptibility artifacts, dropout in regions, but you want to know that it basically is filling the M&I space, and it's not too bad actually, it's pretty good. So check the back of the brain. As you come in, you start to see, once you start seeing the brain, you start to see it over here as well. So it's basically filling the space. You check a few internal structures if you want. But in essence, this data looks reasonably well normalized, so that should be fine. And that's just what you want to check. Just check that the data. Really, when this goes wrong, it goes really wrong, usually because co-registration's failed. So you're applying normalization parameters to images that aren't sitting in line with the structural, so they go horribly, horribly wrong. Okay, so after that, the only other thing I want to talk about today is creating a pipeline, linking these steps together. So it's fine to do each of those steps as we did today, slice timing, realignment, co-registration individually. But if you've got like 50 subjects to do, that's really not feasible. And certainly the likelihood of error goes up dramatically with all the kind of manual file selection. But luckily it's possible to chain together these operations so that you don't have to do that. So if we click batch, I'm going to take you through how we make a pre-processing pipeline. chaining these operations together. Okay, so this is the empty batch. So rather than clicking over here, we can go to this option here, SPM. Now I always start with segment. The reason being, if you want to use something later on in the pipeline, it has to be presented, it has to be created earlier in the pipeline. So we'll start with segment, and you'll see why in a little while. And after segment, I'll put in slice timing. And then realignment, which came after slice timing. Realign, estimate, and reslice. And you can see here, these are stacking up. These are going to be executed in this order here. Spatial, co-registration, estimate. Spatial, normalize, right. Spatial, SPO, spatial, smooth. Okay. So just to remind you, that's SPM, spatial, segment, temporal, slice timing, spatial, realign, estimate, and reslice, co-registration, estimate, normalize, right, and smooth. Now, unfortunately, you can't move these around. You can delete them. You can delete any of them you want if you right-click on it. Should give you the option. Yep, delete or replicate. But you can't just move them around, which is unfortunate. Okay, so let's go and create this pipeline. So the first thing we do in the segment is we give it the T1, if you remember. Okay. We select the forward deformations as before. Well, forward and inverse, that's fine. But we're going to do one thing slightly differently, which is we're going to add to create a bias corrected image. Now the reason for that is because later on we want to use the structural and co-registration, and rather than having to manually select it, I want to be able to use this output image as an input to the next step. So you'll see us use that later on. So slice time and correction, create a new session, and here we select our functional data. You'll have noticed this dependency button has appeared. That's the operation that allows us to chain together operations, saying that the input here is dependent on the output of a previous step. So here we're going to take our task file. So again, we're about to do slice timing, so not the 1:300. Right click, select all. Okay, so the number of slices, if you remember, is 38. This is in the handouts, and it's also in the towards the beginning of this video. The TR. Is 2. The TA. Is 2 minus 2 divided by 38. If you remember this code, this formula is given here. The slice order, remember our data is interleaved ascending. So it's going to be 1 going up in steps of 2 until we get to 37, and then go back to going up in steps of 2. 1 colon 2 colon 37. 38, we can say 38, but it doesn't matter, it only goes as far as 37. 2 colon 2 colon 38. Okay, the reference slice. And that's going to be the middle slice in time, which, if you remember, we said was 2. Okay, so the next step then is we want to do realignment. But rather than selecting the files, because they haven't been created yet if you were a new pipeline, we tell it that the input here is dependent on the output of a previous step, specifically slice timing. So we'll say the input here is dependent on slice timing corrected images. And we say create the mean image only. And that's all we need to change. Okay. Then we go to co-registration. The reference here, so this is why we did segmentation earlier on. So now I can take the bias corrected image, and the source image is a dependence and this is the mean image. It says the image will be moved around to align with the structural. And the last thing then is the other images. And this is the mean image, realigned images. Okay, so bias corrected image, mean image, and realigned images. Normalization, again, new subject. Images to right is dependency. It's going to be our co-registered images from the previous step. And the deformation field comes from segmentation. For deformations. And finally, smoothing. And again, you can change the parameters as we were talking before. You can change it to smooth out by less or more if you wanted to. Normalized images. And that's it. That's a pipeline we can just save. We're going to use this pipeline on the fourth session when we look at automation. We'll turn this pipeline into a script that allows us to basically move into a folder, find the files, and plug them straight in. So I've called it pre-processing pipeline because I've already saved it. That's fine. Now the key, it's going to ask me if I want to write over it, and that's fine. Yes, that's fine. Now the key thing here is you've got a full pipeline. If you want to do a new subject, you just change the T1, and you change these files, the functional data. Everything else is the same. Just press play. Then for a new subject, you change the T1, you change the functional data again here, and press play. Everything else is the same. So you can see there's much less involvement from the person, so much less chance for human error. But what's also nice is then you can easily turn this into a script that automates the whole process. Okay, well that's all I wanted to cover in this first session. We'll next move on to looking at modeling the data at the single subject level. So I hope that's been useful. Feel free to ask any questions at any time. Okay, cheers, thanks.